Hi everyone, our group is Divergent, and today we'll give you a presentation about can Bitcoin serve as a new gold? Here are our group members. My name is Shen Weibing, and I'll give you an introduction. First of all, you may ask, what is Bitcoin? Here we list 3 of the main points. And after we do the literature review, some former studies have labeled Bitcoin as new gold. But we ask that, is that true? In our study, we mainly use 2 methods. The first one is about conditional variance, and the second one is focused on the correlation between some assets. Now let's move to the data. We use 7 time series and view our data at a first glance. Now move to Yunling.
Hello, this is Yunling. In this part, I will focus on the Bitcoin volatility modeling. Let's start with some general features of financial data like the volatility clustering and leverage effect, to construct models that can describe these features and further find out some special properties for Bitcoin. We checked the normality of Bitcoin return and found student T distribution to be a suitable one for residuals. Then the series has no unit root and is tested to be stationary. And besides, ACF plots indicates we only need to model volatility but expected return. We start with the classical Gauch-1-1 with T distribution and found the sum of alpha and beta is slightly larger than 1, considering the stationarity. We explain it by a long memory effect in volatility. To improve this model, we add a constraint and get the I gauge in the right hand side. To illustrate the leverage effect, we construct E gauge and AP arch. And in AP arch model, we also include volatility effects in mean. The positive gamma in E gauge and the negative gamma in the AP arch both lead to the same conclusion that Bitcoin has an inverse leverage effect, which means the positive pulse values of these AT will increase the volatility more than the negative ones. Next, we turn to test our models. Ignoring the intercept, all parameters are significant, and all models are shown to be adequate by the ACF plots of squared residuals. Before fitting the models, we left out 21 data, and here we can use AIC-BIC criterions and the MSE of these 21-step forecasts to select our models. And here we recommend AP Arch M model. Next, welcome my teammate Tu Jingjing to introduce the comparison between Bitcoin and other assets.
Hi, I'm Tu Jingjing. In last step, we conclude that APR is a better volatility model for Bitcoin. Now we analyze and compare the volatility structure of the 6 assets and apply the APR T11 model. APR T11 model can be expressed as this. Alpha and beta are respectively the arch and gauge coefficient. Gamma will capture the leverage effect of the returns. And our result table reports the parameter obtained by applying the APR development model. We can see gamma is negative with larger than 5% level of significance in terms of Bitcoin, gold, and silver. And the other 4 gamma are positive with 1% level of significance. According to that, we find Bitcoin is more similar to gold and silver than to the other assets. They do not have a very significant leverage parameter gamma, but they all have an inverse leverage effect, which tend to have a higher volatility if the formal-based residual was positive. And the other 4 assets have a higher positive gamma, indicating that volatility rises if last days return is negative. As for Taylor effect, the power parameter data for Bitcoin, gold, WTI, S&P 500, and MSCI World is around 1, and the data for silver and MSCI EM50 on the other hand is around 2. Okay, next Guo Yutong and Youren will show the method 2.2.
Hi, I'm Guo Yutong. Let me show you the method we use to find the properties of correlation between assets. Multivariate variance covariance modeling. In order to compare the similarities and differences between Bitcoin and gold in relation to the market and assets from a diversified perspective, we used the Big Gauge model, which was proposed by Robert Engel and Kenneth Corona in 1995. First, we let RT be a k-dimensional vector of observations at time t. It is denoted as we showed. And then we model conditional heteroscedasticity with the formula 1. So that the diagonal Big Gauge model could be used to determine the metric process Ht. It is defined as a formula 2 and 3. Let's set k equals to 2 so that we could explore the correlation between Bitcoin and gold in pairs with other assets by analyzing the centralized residues using the Big Gauge model. Next, Youren would show the result of this part.
Thanks, Yutong. Next, I'll be discussing about the results in part 2.2. We'll be looking at the dynamic correlation between Bitcoin and SP 500, and we'll compare it to the dynamic correlation between gold and SP 500. So for our plots, we can actually see the gray lines. These are the raw BKK correlations, and we apply Swarovski-Golay smoothing to get the red smoothed correlations. So for our plot, we can see the correlations are extremely volatile and they fluctuate between negative to positive throughout the years, showing that there is no stable correlation. This may largely due to Bitcoin has very high and erratic returns. When market crash during the 2020 pandemic, which is highlighted in the blue region here, we can actually see the correlation increase from negative to positive. This shows that Bitcoin is not a good hedge, but rather just an investment asset. Next, we look at the gold and SP 500 plot. This is much different from the previous plot, as we can see the volatility is much less and the values are actually mainly negative. The negative values show that gold can be a very good hedge for S&P 500. However, during the market crash this time, we can see a sharp increase from the correlation from negative to positive, showing that gold failed to hedge during this period. However, whether this is a one-time exception or maybe gold has started to lose its hedging power, we need more data to verify it. Last but not least, we have the Bitcoin and gold plot. And if we assume Bitcoin is very similar to gold, we will actually expect a positive and stable correlation plot. However, from our plot, we can see the correlation fluctuates between negative to positive again, showing that there's no stable plot. Therefore, Bitcoin is not similar to gold. And next, we will let Weibing to wrap up and draw the conclusion.
Now let's come to the conclusion part. First, for conditional variance, although Bitcoin and gold share some similarity on long memory, the difference is that Bitcoin does not have a significant inverse leverage effect as gold. Second, for dynamic correlation, the differences are more. First, Bitcoin doesn't have negative correlation with another asset. And when market is under distress, Bitcoin cannot serve as hedge. So in a nutshell, to answer the questions we raised at the very beginning, Bitcoin may not serve as a new gold. That's all for today. Thank you for your attention.